All right, so some of you are probably thinking right now, man, synthetic division is great because there anything that can go wrong with it? Because we have these two different methods that accomplish the same thing. And actually, there is one situation that you kind of have to watch out for when you're doing synthetic division. It really comes into play when you have a factor that's not just like x plus or x minus something. And it really matters when you're asked to factor something completely. So let's say that this term right here, 2x minus 1, is a factor of that polynomial. And we want to use it to actually break this guy down and factor it. So I went ahead and just showed the work here for the long division, because I'm going to put these side by side. You can just copy that down as is. I would do that though so you have it on hands. If you're going to use synthetic division, outside the little box, you're supposed to have the roots. Now to find the root of this, you just set it equal to 0 and solve. If you have 2x minus 1 equals 0, you're of course going to get x equals 1/2. So on the outside of your division box here, we do have to have a 1/2 or a 0.5. That's the first difference there. We're going to go ahead and copy down everything else as is on the inside. I have a 2, a 9, a 7, and a -6 for the inside of my box right here. And I'm going to set it up just like I always do. So I drag down the 2. Multiply 1/2 times 2 is 1. And then I add these together. 9 and 1 is going to get me 10 here. And 1/2 times 10 is 5. Add those, I get 12. 1/2 times 12 is 6. No remainder. So when I look at my answer right here, I have a no remainder. That's my linear term. My constant term, sorry, keep doing that. My constant term, my linear term, my quadratic term, it's going to be 2x squared plus 10x plus 12. If you look, these are the same method. We should get the exact same answer, but we did not. We got two different answers here from dividing essentially the same problem. The difference comes in when we put a 1/2 right here. We did the original guy, and we put a 1/2 here. Synthetic division thinks that what we divided by, so we have this guy right here, it really thinks what we divided by was x minus 1/2. It sees a root right here, and it doesn't know, oh, that was really 2x minus 1. It thinks, oh, fine, it was x minus 1/2. Whereas if you do this problem right here, you can see right away that this times this equals this. So if there is a factor where you have to do some solving, not just say what x equals, which is regular x here, you have to do a little bit of rearranging if you have this answer. Because normally we don't have fractions like this. It's not like it's wrong. But what we would actually do, you can take a GCF of 2 out of this guy. If you do that, you get x squared plus 5x plus 6. And what I'm going to do with that 2 I just took out is actually distribute it into this parenthesis. If you do that, you get 2x and the minus 1. So you have to do a little bit of algebraic manipulation. Like if you take the 2 out of here and put it in here, then you get what you would expect to get right here. So if you have a number in front of the x on your factor, be aware you might have to like modify things a little bit so you get what you are supposed to. In either case, when you get this answer right here, because this times this gets you back to the original, this isn't factored completely like the instruction asked, because my parenthesis over here actually does factor further. My final answer, you would just do magic numbers on the right parenthesis. It's going to be x plus 2 times x plus 3. So completely factored, this is going to be our answer.